Home automation system, great. What about else? Okay, great, Taran. You have worked on voice interfaces, right? Yes, great. Only 2 systems? We have a lot more people connected over here. Okay, you attended a workshop. Did you design any system, Mr. Naveen? Great. So you have, Vignesh, you have implemented some AI-based systems, the disease detection. That has an implementation of AI also apart from IoT. Great. So IoT is becoming a very reality of our today's system. There is nothing which is left with IoT. And if we are, if IoT is all around us in such a way, we have to be very careful. We have to be very thoughtful about the security related to it, because design is a one aspect. And think of a situation that you have designed a system and someone with an evil intention, with an evil mind, has taken control of your system. And now he is asking you to give you the ransom. You have designed a home automation system to control your lights and home appliances, maybe your fridge appliance, maybe your lighting appliance. And maybe I am the evil person who has taken control of your home automation system. I'm just switching lights on and off of your home. Well, do you think, is it a good situation? Have you thought about this? Is it possible or not? Yeah, great. So it is possible and it is happening. It is not only possible, but it is happening. How many of you have heard about the Jeep attack that has happened in USA? That was a very talk of the town attack. The Jeep, the Jeep was being taken control by some hackers, and he has driven it on highway and killed many of the peoples. Apart from, he has taken the huge amount of ransom from the Jeep manufacturer. How many of you have known about it? Or think of a situation, you are driving in a connected car and just you got locked in the mid of the highway, and you got a message suddenly pops up onto your dashboard screen, give this much amount of Bitcoin. Otherwise, your car will be stuck. Okay, leave that is a little more further examples. How many of you have been faced a situation where your computer is got locked by some malware or by some viruses or something like that? Have you heard or have you faced any such situation before? Any one of you have faced any situation like this? Or maybe you have heard about it. Maybe you have read about this. Okay. Recently, you must have read at the news that Twitter was got hacked through its internal networks, and the tweets were the ransom tweets were made in the name of the big personalities. So there are in number of use cases and number of scenarios that has happened previously, and it is not a recent thing. It has been happening over the years. It is not only just IoT, but it is the IT systems, it is the personal systems, all the places where if there are the good people, so there are the evil people also. And if there is a evil people around you, so anything could happen to your system. So definitely once we are from the Great. Yeah. So once we are into the design of any of the system, the security is an underlying factor of that. And from the design of the system, we should start thinking about that, how we can make it secure. So security, not only the IoT, but it is the security is in the life cycle of any of the system. And that's how it should be implemented. So, so you all of you are going to be some, either you have designed or you will be designing a lots of kind of IoT systems, and even the further AI and ML based systems later on. All of you are engineering, so into engineering, so we will be designing such kind of things. So that's why it is very important to know about the aspects of the security, and where the threats are, what are the surfaces, uh, what are the leak surfaces, and how we can audit about the security, and thereafter what are the solutions are available, how we can make our systems secure. So these all things that should be into the knowledge, and based on this, these two master classes are planned. So in this session, these two sessions is agenda for these two sessions will be revolving around the security matters, that how and why your security matters. Thereafter, how do we discover about the security? And thereafter, how we can secure, what are the surfaces, what are the attack surfaces from your chip to cloud level. And thereafter, we will be talking about some of the attacks. We will be talking about some of the case scenarios which is necessary into the industrial IoT and Industry 4.0 applications, because it is not only the personal IoT we are going to talk about. Post-COVID scenario, it has happened like the industrial IoT scenarios. Just a few seconds, some network issue is there. I'm just working on it. Okay, great. So in this session, I'm going to discuss the about these security aspects. Thereafter, different security enablers that would be discussed, and how we can mitigate if there is a security hole. So there must be some way to mitigate those securities. So that's what will be discussed in these two sessions. And thereafter, we will be having some demonstration of the IoT security attacks later also in this. So these two things during these 2 days session. And so I request you to join all these 2 days session, and it will have all the discussions and all the aspects of talk related to the security from the chip to the cloud. It is not from the edge to the cloud. We are going to talk in these two sessions. We are going to talk about the security from the chip to the cloud level, because it is the IoT which is implemented based on the embedded systems. And if we are talking about the embedded systems, so it starts from the chip level. So that's why we are going to cover all these two things. And later on, we will be next day, we will be discussing about some of the opportunities what are available in the IoT security domain and IoT auditor domain. And definitely, we will have the question and answer sessions on both of the days. So it will be a fruitful session for all of you, I hope. And I can say lots of faces which have been previously connected with us. So can you just have you attended if any of our previous sessions? So you can write just yes, so that I can be a little more excited. When you can see that previously you have attended our sessions. Yes. So these 2 day session, okay, who have attended, you can write yes. Okay, so these 2 day sessions, so you know my face perhaps. So I'm Amit, and I handle the technical division of PRGYATMIKA. And next day session will be conducted by Mr. Hers. He is a security consultant with us. He's AWS certified. So he will be discussing you about the different security attacks and the mitigations and all the plan. And in today's sessions, I will be specifically talking about the security aspects related to the chip to the cloud level. Great. And as most of you know that PRGYATMIKA organization in the domain of the consultancy training, and we have in-house R&D and in the embedded systems, IoT, industrial IoT, embedded electric vehicles, automotive electronics, and industrial electronics. And we have support for all the bodies from the industry to the academics. So for industries, government bodies, and startups, we have the support related to the R&D and the technology support. For universities and colleges, we set up labs and the training programs and all the things. So we have been actively working in these COVID days also related to the trainings and the academic support for all the universities and the government training programs. So I hope you all will have been got benefited with our programs. So we are in a connected digital world, and with a new normal, it is going to accelerate at a very fast pace, because once we have to maintain this social distancing, so we are very much dependent upon the things. Way back from the 19th century, that's 1875, it was the personal connectivity that the global connectivity started, I can say, where the from the people to the smaller societies, and then to the state, the countries, all the things we're getting into the connected, and we can read the stories into the histories that this man has discovered maybe the USA part, this man has discovered the European part, and this man has discovered the Indian part, or somewhat like that. So this was a need of the global connectivity that all was there. And from the global connectivity, it all we all are going into the personal connectivity. Actually, once it started with a kind of thing that people started searching about the different part of the world, and once they have searched about the different part of the world, the information has coming in, and now people have started of finding ways to get the communication through the means of the gadget. The people to people communication is a little decreasing, and the gadget to gadget communication has started increasing. That's a way forward. And if you can see the new in the new normal, where we have to maintain this social distancing, this gadget to gadget communication is going to be at a very large pace. So earlier it was projected around that there will be 50 billions of things. These things are your devices, which is IoT devices, I can say, will be on a network. And this projection is going to be false. Definitely by 2025, it must be around 75 or hundreds of billions of devices are going to be on on a IoT network. And if this is a huge number of IoT devices are going to be on a network, so definitely it is posing a very great risk for our lives also, because we are heavily dependent on these things. Just starting from your electronic toothbrush to the night you are going to sleep, your night sleeping pill device, or maybe your alarm device, everything is on a network now. And if we are on a network, so constantly we are monitored. We are on a threat of, I'm not saying that we are getting monitored, but we are on a threat of getting monitored, and we are on a threat of getting controlled if we are not we are not on a secured network. And that's what it is. We purchase any of the device, you are not sure about security, authenticity, on authorization of those devices until and unless you have not about them. So that's why uh, we all have to be very concerned about these digital world devices. And if I just see the categorization about these installed devices in the different categories, that the prominent categories are your in which the IoT is going to take place is the automotive devices, the consumer electronics devices, the business IoT devices, and thereafter the vertical business devices, which is used for making good of the people great. So you can see the number of increments, and the in this 2020 they say around 25 billions of the devices like this is going to be. And where the consumer IoT, which is very much related to our day-to-day life, the consumer IoT and automotive IoT has a very great impact on the IoT world. So if these are the number of devices which is increasing day by day on the network, so there is an increasing risk of getting their infections, getting their infected, getting their controlled by some else. That's what this breakdown says, and this is a breakdown that has been presented by Nokia this year. So you can just see a comparison that in 2019, if I'm talking about this, the IoT devices, the 16.17 is the IoT devices that was there on a risk. And in this 2020, it had just doubled up. 32.72% of the IoT devices who are on the risk and who have been compromised or who have been threatened. So number of the devices are increasing. Same way, their threat level, their chance of compromisation, their chance of getting the compromisation of the security, all these increased. So that's why we should have some way, we should have some mechanism to access these security breaches, to access that how much device could be compromised, and how much we can secure these IoT devices. So these threats could be into different way, and there are the different threat models. It could be around us. Just starting from the very initial, the denial of services attack, which could be a distributed one. Just think of a scenario where the distributed denial of services attack, which can lead into the Internet of Things, into a botnet of things, that the botnet has just infected one device, and all the things, just one thing it has infected, and the all the other is connected on the same network is got infected by that botnet, and suddenly on the cloud, on the cloud which is through which that things were connected, has started getting the denial of services attack. So this is a very great threat. The denial of service attack is a very great threat which happens for these home or IoT devices specifically, because they are very prone to attacks. They have very easy attack surfaces. To your car, which I was talking about, that home IoT as an attack surface, it could be. So maybe your connected car could be your next target, where you have to pay ransom to some of the hacker to just unlock your car while you are moving on a highway. To your home, maybe you are using the default passwords, and that has happened. There is a very good data you can see on their on bbc.com, the electronics section, or maybe which.co.uk electronics section, if you can see, there are millions of such cases which has happened where people are using the default passwords for their home IoT devices, maybe your access control systems, and someone has just breached into your system. And once you have gone out of your home and once you have came back, you are not got authorized. You are the owner of the home, and you have not been admitted to your house only. So these things have happened related to these access control systems, related to the cameras also, that has happened. The cams which are peeping into the our lives, and that could be turned into a completely that those cams could be turned into completely insecure devices through which hacked or your information could be stealed out. Maybe your smartphone could be stolen. Maybe your smartphone could be taken control, and maybe in the night when you are sleeping, that could be used to record the things. So these all things are happening, and these all things are possibly possible with these IoT attack surfaces because of the nature of the design of these IoT devices, which I'm going to talk later on. So this is incorrect access control could be a very good model for your IoT attack. The majority of attacks happen through these outdated softwares. Maybe your firmware, which you are not updating continuously. Every firmware, it is a lying truth. It is a very truth that every firmware that has been designed has some level of a bug into this, whether it is a software, whether it is a firmware, everything, some or more level of bug remain over there. And even those bugs and the clock which is running to execute those firmware, that must have some level of glitches. You can someday I will be conducting the physical security session. Maybe we have launched this series of these IoT security master classes. So maybe in one of the master class, I will be talking about the physical security measures. So where I will be discussing more about the physical attacks on the chip, where I can show you that how the clock can be compromised, how the glitch in the clock, and how the glitch in your firmware could lead to get complete control over your embedded device. Those really lead to that outdated software, means your software has some bug, and those softwares could be used to take control of your firmware device, your IoT device, and that can be used for the exploitation of your network even. So not only the device, but it can exploit up to the cloud level if it is not secure. So these are the different set models we have. And it is not only related to the firmware and software I'm talking about, but it can happen to your hardware level also. How many of you use the smart plugs? Smart plugs, how many of you have used? Or smart plugs, you know? How many of you are familiar with smart plugs? Okay, you have heard about it. None of you have used smart plugs yet? Keep session interactive. Just yes or no. Nothing is going to happen. Great. So you have used, Mr. Suresh, you have used it. Great. So that smart plug, which is used to control the devices over the Wi-Fi or over the internet, that not only a security hole in terms of the network, but a hardware hole also. I'm just showing you the PCB of one of the smart plug, which has been I have just broken it out. I will not take the name in this open session, but yes, most of the smart plugs which you find on Amazon or such kind of websites had similar kind of PCBs. You can see here, this smart plug, this is the backside of that smart plug. And can anyone tell me about the abnormality in this design? What is abnormal? What can anyone tell me in this? What it can? The USB port is there in all the smart plugs for the charging or such kind of things, or for even the uploads, the data uploads also. But there is something abnormal in this design, and I can tell you that abnormality doesn't lead past to either EU and CE standards, but this smart plug is sold based on a CE standard that has passed the CE standards also. I don't know how. Okay. Okay. I just tell you. You can see I've just noted these two things over here. Noise level is the one thing. Yeah. I can see you. This is the mains neutral. I have just pointed out. And another, I think I have pointed out this cell of USB socket. And as per the EU or the CE guidelines, the mains neutral and the USB neutral, the mains neutral, that is the AC neutral, and the DC neutral should not be onto the same ground plane. And if you see that both of them are on the same ground plane. And if this is on a same ground plane, there is an increasing chance of catching this fire. And how it can catch fire, not only by the maybe the glitches into the mains, but even a person who can control, who can compromise this smart plug remotely can make the catch fire, because by overloading this USB and the mains neutral. So by overloading the load onto this smart plug, by spoofing it, one can one can easily make catch fire this smart plug without your knowledge. So not only this IoT security or is not only related to the network security or the cloud level security or the net or the I can say the things level security, but it is also very much important related to talking about the hardware level security. So we should also look at where when we are talking about the IoT security, so we should also be looking at the hardware level security. And this is a one level example that I'm showing to you. So this is not only a design flow, but this design flow can lead to hacking of the device and compromising it to causing it a fire. Here is audit of this has been done by some group of experts, and I'm sharing you the. So this is a NCC group of security consultants, and they have just audited this device. And what they found about this, I'm just sharing to you that related to the network, they have found it out that they are sending keys over the default Zigbee, their default Zigbee key, and they were openly sharing their Zigbee keys. So maybe this device, apart from the MQTT communications, this smart plug is communicating through the Zigbee into the home network, and they were sharing their Zigbee keys, and which leads to any attacker into enter into that their Zigbee network of the home, and that's how he can take control of the further MQTT and the cloud network. And these devices were found to be sharing their GPS coordinates of the user also, but that is not required at all. But still they were sharing their GPS coordinates, and I don't know why it has been designed like that. Here is another thing that has been found, that none of their firmware were it. So the firmwares and the HTTP communication which were happening over the network was none of that was encrypted, and it was just a plain text communications. Even the passwords which were used to store these devices were just plain text passwords, and there was a kind of no security kind of maintenance was there. So it is just any of the smart plug which is available on XYZ e-commerce website, and this is the kind of report with them. Out of the 6 smart doorbells he has also tested, none of they are particularly smart or secure. And he has actually named it into this report that the how the data breach is happening, that without giving the complete identities, these manufacturers, all of you know that from where, from which all sources, from which country specifically these devices are coming in, and none of the manufacturers of this particular country has given their identity, and their associated cloud service providers, they have formed such a complex network that it is very hard to trace that where the data is going from the for the foreign supply chain. So these are the very important aspects of any of the XYZ IoT device which you purchase from any of the network, because any of the IoT device related to their security, and just to audit about them. Mr. Naveen, you have some query, you can put it to the chat window. Maybe you have raised. Apart from your, it has been just reported that apart from your locations, they can just, if it is to be gathered, so maybe there your load uses data, where you are, when you are using the, what type of devices, what are the loads that you are using with your plugs, and which locations you are using. So all these kind of data, maybe if you are connecting your smartphone, so for the charging of these devices, so maybe some data, so those smart ports can gather the other data from your smartphones also. So these kind of things that may be gathered from your device, not only the parameters, but also the data parameters that can be gathered from your devices by connecting to these smart plugs. So this attack is not a very new. It has been, and this is not a new thing that has happened to the industry. People are knowing about it, and here I have just laid down few of the attacks. Maybe there are lots of attack that has happened after May 18 also. I have not, it is not my primary agenda to discuss about those attacks. You can find and I can share you the reports which has happened till now. And it has started happening from the way back. And we have the valid data from the 1970. These IoT attacks has started happening. Just few of the attacks that, as I have mentioned over here, just these are the primary attacks that has happened related to the IoT. So it is not only to the network, because but it started from the PLC level into the plants, into the nuclear plants, to the TLS level, to the Wi-Fi level, and almost all the Wi-Fis are now to be cracked. You can see that every Wi-Fi key, if you are on a WPA2 key, so it could be cracked very easily. So not only the network, but the processor, the PLCs, the Wi-Fi network, all these are prone to get cracked and prone to get hacked and prone to get compromised. The physical layer and the application layer, these two are at the uppermost and the lowermost level. So application layer is at the topmost layer and physical layer is at the bottom layer of any of the network communication. So these two are very prone to get compromised. So we have to be very careful about design of these two layer systems whenever we are. So either it could be through the hardware level, maybe because at the physical level you have the cables and the hardware. So at the hardware level the compromisation could happen, or at the top level, the application level, the software level, the compromisation could happen. So these two are the very important layers which needs to be carefully designed whenever we are designing the systems, so that we can avoid some kind of attacks. But still, there mid-layer attacks also happen, that if someone has entered into your network by any of the network layers, so it can alter the other layers of your network communication also. So it is just some few, and I'm not going to discuss about any one of them as of now, as it is not my agenda. It is just for your uh, knowledge purpose. So uh, why IoT is at such a why we are talking about the IoT attacks so much? Why it has become so much important about the of the IoT security, IoT attacks, and all these things? Because of a certain nature of the IoT systems. As all of you know, IoT involves IoT is the Internet of Things, and things are your devices, which gets the networked communications. So it involves a very heterogeneous nature of devices. There are the various different nature of devices which are connected over the IoT network, and all of them are sharing a very sensitive data. All of them are collecting the data which is very related to your day-to-day life, of your choices, of your lifestyle, of your information, which maybe which needs to remain secure. Maybe your health information, maybe baby monitors, maybe your kind of personal health gadgets. So all these are very important aspects of your data, which needs not to be altered. It is not only the collection of the data, but so with a person with some evil mind can alter your data. Think of your insulin taking a device, which gives you any IoT device, which takes care of your giving the exact level of insulin which is required for your body. And if someone has taken control of that and has altered that level of the insulin, so that is actually a threat for your health. So that's why IoT is IoT a collection is a network of the very heterogeneous type of the devices, and all of them are connected always. So that's why it is very important to talk about the IoT systems security. And secondly, IoT devices, these IoT devices are always in an uncontrolled environment. Most of the times, if it is a IT system, so you know that it is within your office premises, or maybe within your home network, home premise. But IoT devices, there are lots of IoT devices who are there in the open network. The weather information gathering devices, maybe some kind of transportation, IoT based transportation devices. So maybe your camera applications, which is covering the smart city, maybe the kind of security gadgets, maybe the alarms. So there are lots of kinds of IoT devices who are there in uncontrolled environment, and which is not in the control of their manufacturer, which is not in the direct control of their end users also. And because they are just put to gather the information, and if someone has taken the control over the open network, because the cities are now going to be open Wi-Fi, have the open Wi-Fi communication, and most of the IoT devices based on the LoRa and some network, based on the LoRa and the some other Wi-Fi networks are getting connected over it. So they are going to be on in an uncontrolled environment. So that's why the deployment related to the security related to the deployment, and the security related to their access and their designs is very important to talk about. Secondly, this we have talked about their nature of the IoT devices and their installations, their implementations. And we have a constraint related to the IoT device design also. You may think of that if we have such prone to security related to the IoT devices, so why can't we make devices secure when they are manufactured? why we can't give some kind of antivirus into that or something like that, or can give some level of authentication or authorization into that? Do you have some, do you think like that something? Why, just like your computer systems, we these IoT devices are working like any computer system. So as in the computer system, you have some level of the authorizations, access control systems, and the antivirus systems and all such, which can be implemented at the manufacturer side only, and you don't worry much about their securities, the compromisations. So can't we implement such kind of things in IoT devices also? Do you think like that? Have you ever thought like this? Can we implement the IT security? Can we implement the measures of IT security into IoT security also? What's your answer? Yes or no? We have a well-defined IoT security measures. Movie most of you are knowing about it. We have the very, very well-defined IoT security measures, and lots of companies are working in the IoT security domain. So can we implement those IT security measures into the IoT security domain also? Only you have two answers. Others are thinking about it. Okay. Okay. So we can, yes. Okay. So let me clear it. So we have the IT security measures, and that requires a large volume of computation powers. It is always designed like the a separate structure for the IoT devices. The IoT communication structure is separate, always designed in the cloud level, Mr. Hemant. So, so I just make it little clear, and you will also agree with me. So, what happens that if we are talking about the IT security, so it requires, apart from the various measures of the encryptions, the antiviruses, the authentications and authorizations, it requires a good amount of computation power for that. But if once we are talking about the IoT security, the IoT devices, first thing that IoT devices are very lightweight in nature. What that lightweight means that we don't have enough processing capabilities, we don't have enough memories, and the size of these IoT devices are also very less. You can see that most of the times you will not be able to recognize that any device is present over here. Maybe any Wi-Fi camera which is connected on any of the door, or maybe just a sensor which is used to gather the presence of any person in this room, or maybe any sensor which is used to gather the weather information. Maybe you will not be able to see them around you, but they are there and they are gathering the information, and they also needs to be secured enough. So we have a very practical constraint of the performance, the reliability of these IoT devices around us, because we don't have enough resources available with these IoT devices. And if we don't have enough resources available for these IoT devices with them, so then implementing security with those devices is a challenge, because you don't have enough memory available through which you can run the encryption mechanisms, or you don't have enough memory available with those IoT devices on which you can run some kind of antivirus solutions or something like that. Thereafter, these devices are changing their identities more and often. Maybe they are connected in a network as of now, and suddenly their device needs to be ported to another network. So, so assigning identities, it is a just-in-time registration facilities that needs to be given to these devices, and through the means of the authentications and authorizations. And it is the roles and privileges also that these needs to be uh, identified for those devices, because the data which is gathered, which has been gathered from these devices, so we have to set a level of access for these data, that who can access which data from these device. The data will be gathered raw from these devices, and from the user level, we have to set the accesses for the privilege based on the privileges of those data items. So that's why it becomes a very complicated scenario for these IoT devices to gather the information, to store it into a distributed network, and to provide security. So that's why I can say that the IoT fabric, this IoT fabric is means the IoT layer is a very uh, porous, and anyone can attack from anywhere in this, because it is not a complete system in itself. It has the multiple components into it, from the hardware to the cloud level. There are the multiple attack surfaces into this IoT architecture, and that's why it's a thing of talk. Yes. I think someone has raised hand, and he can put his question into the chat window. If you have any question, you can put into the chat window side by side. So if I just summarize, so it is the deployment, the IoT devices deployment, because if it is the IT system, so you are taking care of the security of your IT devices, your computing devices, which is placed in your office or home, and somewhat you are able to manage the security of that. But think of the scenarios of billions of IoT devices connected on any of the cloud network, and how they are deployed. Maybe think of a hotel chain. That hotel chain has implemented IoT solution for gathering all the kind of environment data, the people presence data, the transportation data, the kitchen appliances data, all the kind of data. And that hotel chain has hundreds of hotels throughout the world. So deployment level is in terms of the millions, and that securing those millions of devices, and gathering the data and managing the data through those millions of devices onto a same cloud, it is a very complex job. And that's why the larger scale deployment of IoT devices lead to the security challenges first. Thereafter, it is the geographically distributed IoT nodes are there. The same scenario which I have discussed you, that maybe that hotel chain has hundreds of hotels throughout the world. So managing the data from the different hotels through the different IoT nodes, and again giving a level of security as per the geographical standards, because every maybe in the next session I will be discussing you about the standards of IoT security, and different countries have different standards of IoT security. So it also becomes a very important aspect while we are implementing the security, to implement the security standard, to implement the data breach standard, because in some of the countries, data breach is a very critical thing. You have to lose your everything if the data has got breached. And in some of the countries, data breach is just a kind of a thing which goes into the third or fourth page of a newspaper, or maybe even doesn't take place in the newspaper. And that is a very common thing. So just think of a scenarios of this, and how stringent policies are still related to these IoT security. And that's why implementing security for all these kind of different geographical distributed network, for all the geographical locations, and giving the data as per their policies is a challenging thing, and it is a complex scenario. And we have the various levels of data that is coming in from the different sensors, and there are the various sensitivity level of those data items are. Maybe some health data is there, which is a very complex one. to maybe some weather information. So that is a less complexity. Maybe some transportation data, which has a higher level of complexity, which needs a higher level of security, to data which is just of a consumption of some load, maybe some power consumption loads, which has a less level of security. So there are the different diversified data variation ranges are there, and that travels through the same IoT network. So designing the security, because it is not possible to give the same level of security, same level of secure architecture to all the data items, and it becomes, because we have to save on the cost of the system also. If we are giving the same level of security, if we are implementing the highest level of security for all the data items, we will be finally increasing the cost of the system also, and that may not be uh, a thing of a choice for the industry, as per the budget and as per the implementation. So you have to be, it is also a challenging thing to decide about that which data needs to be what level of security. So that security auditor takes care of that thing, that which level of data and what are the attack surfaces needs to which kind of security, and which kind of data that needs to be secured enough, and which kind of data that can have a little lesser level of security also. And always all these IoT data are in a threat environment. So that's why the data processing is always a challenging thing in IoT, because of maybe some attack has happened and that has taken over the memory of your device, that has consumed the processing capacity of your device, and that may create a security challenge for your devices. So that's why these are the different security challenges which has with your IoT devices. You can go through this slide that which I've talked about the traditional IT versus IoT security. So in case of the IoT devices, there are we don't have the traditional endpoints like in the IT industry. We have a set endpoints, like your office computer will connect to the hub, and hub will connect to the gateway. So these gateways are within your premises, or it is set. It always remains set. But if we are talking about the IoT devices, so even the gateways may keep changing because of the communication with the different clouds, and maybe the nature of the storage of data, different data to the different cloud. We also have some architecture where we have various data coming in through the sensors, and we store those data items to the different clouds. The same sensor is storing the different data to different clouds, and for that they are connecting to the different gateways. So that's why the gateways, and it is not a very fixed endpoint that we have available in the IoT devices. So that's why IoT security is a little more challenging compared to the IT security. And IoT devices are deployed in uncharacteristics locations to be handled by very different traditional IT in terms of management, monitoring, and services. Secondly, that your IT devices are your computing devices. IT devices means the computing devices I'm talking about are open. They have some interfaces like your computer, your laptop, your desktop, your mobile phone has the interfaces through which you can debug it, through which you can interact with it. But any IoT device, which is just a sensor, which is gathering the data of the temperature or humidity, there is no interface to it. It is just a black box for you. If you don't know about the IoT, if you don't know about the embedded systems, you are just a serviceman, you are just a technician. So it is just a black box for you, as the smart plug is a black box for you, until unless you have not opened it, you have not seen about the security vulnerabilities in this. So IoT devices are just a black box for you in terms of their operations, the stage, the software configurations, or anything. So that's how this is. This is a very complex. This is a very tough to manage about their security compared to these traditional IT devices. So that's why all the traditional IT measures, IT uh, security parameters we have, we are not able to apply those IT security parameters for the security of these IoT devices, and even not for the cloud applications also, the IoT cloud applications also. These security parameters are exactly implemented. We have to make changes, and we will be discussing in the next session about the kind of solutions available, which is there for the security implementations for these IoT devices from the hardware level to the cloud. How do we do the authentications and authorizations in the IoT cloud? So this is the differentiating factor which is there with the IT and IoT. So next time, if someone asks you, you can boldly say that yes, we are not able to apply all the IT security parameters into the IoT security parameters as it is. We have to make changes, or we have to find some new ways for it. So do you agree with this? Just say yes to me if you agree, or if you don't, so you can also let me your reason. If one disagrees, he is also welcome to put his view. We can have. Great. So all agrees. I'm having very few answers. Other people are not finding it interesting. Great. So, Mr. Hemant, I will answer your question at the end. So here I have talked about the IoT and security measures. And IoT is largely related to your home security, home IoT, largely we think about it. And industrial IoT, that is very much necessary to talk about, because we don't want our manufacturings, we don't our industries to go down due to scenarios which has happened just now, and which is happening in most part of the world as of now, that lot of lockdown and everything is happening. So at least industries should get going. Our production should not get held up. Otherwise, it can create a massive bad situation into the supply chain also. So that's why industrial IoT and Industry 4.0 is going to be implemented largely into the uh, world, and you have to also make yourself prepared enough, not for the clerical jobs now, but for the kind of implementation guys who can implement, who can work on a collaborative module with the machines. So that is the future, and that is going to happen. I'm not talking about the very a future very far, but it is going to happen. And most of the factories, if you will see the reports of the most of the factories which were keep running during these lockdown days also, so they have implemented these Industry 4.0 applications, and they are working in the collaborative module. So collaborations with the cobots are working there. The humans and the robots both are working together. Earlier we were thinking of a robotic solutions, but now it is the cobotic solutions. Those are working in these factories, and those cobots controlled. Those cobots have the control from the factory, working in the factory, have the control from the office itself. It is the Industry 4.0 applications are there. So here I'm giving you a difference, that what is there in the in a normal industrial IoT application, I can say, or industry 2.0, industry 3.0 application is on our left side of the screen. So here it is the industry 3.0, a generic industry process. And here it has implemented the industry 4.0 applications. And it is, industry 4.0 implementation is there, which has eased our job very fast. It has given a very good level of a communication. It has connected directly your end customer to the factory, but at the same time, it has opened a very great attack surfaces because we are now connected. Our end factory is directly connected to the end customer. So who is producing is directly connected to the person who is consuming. So if direct connection has happened, so lots of attack surfaces has also opened, which were previously in the layers. Like you can see over here that in this left side, if you can see that we have in the factories, we have the PLCs, the machines, which is giving some kind of automation, and thereafter the HMI interfaces, the human machine interfaces. So you have to program those devices to work on. So that HMI interfaces give that kind of flexibility that you have to program those devices to give some kind of a production. And the HMI interfaces are controlled by the monitoring of these HMI interfaces and the PLC systems are being done by the SCADA systems. And these SCADA systems are programmed and monitored manually through the mesh systems. So this is the manual, this is the human which is working at this mesh system, working through the papers, taking the control from the top level of management, doing the control through the SCADA systems and programming these HMI interfaces to control the PLC system. So there is a very less level of security attack in these kind of systems because it is the human which is it is the one of the kind of a person of the factory who is having the authority, who is well known with these systems, are actually controlling these machines. So this is a generic industry process we have. And if the factory is well enough, so it can have the ERP and the cloud systems also, but it is not always very much necessary. So it starts with generally a mesh systems to goes to the PLC and HVAC systems in a generic industry process. But if this industry 4.0 implementation has happened, so in this left side system in a generic industry process, it is a generic a kind of the factories which is working as of now. So like any XYZ company is producing some car, that car is been produced into the factory, that comes to the distributor, to the showroom, and then to the end consumer. So there is a very less chance of getting the compromisation of the manufacturing of the car by these any of the attacker into this, because these are the authorized persons who are working into this system. But think of a scenario that you want some customization in the car and you directly give a design to your company that I want my steering wheels to be little higher, or maybe my seat to be little flat or something like that. And you have given your own design to the company, and the company is producing the car without changing in its own assembly line as per your requirements. So you are directly, you as an end consumer is directly communicating to the factory. But at the same time, that data you have sent to the company, that may get compromised into this level of communication. And maybe you have ordered for a red car, and that car and someone, the evil mind has changed it into a cherry. So you will get you will get a cherry color car in place of the red color car. That may happen in this industry 4.2 application, because your business systems and your customer interaction and operational systems, all these are on the top layer. All these are communicating to each other. All these are on a top layer. So that's why it is Industry 4.0 applications also have a necessity to implementations of these IoT security. And it is not only the IoT security, but it is the industrial IoT security that is being talked about. So IoT security not only talks about the devices, but it also talks about devices, but it also talks about the hardwares. It also talks about the processes, and it also talks about the levels of the communications. So 4.0, we have the software agents, we have the communication protocols, we have the automation devices through the cloud. So we have the agents for the automation and for cycle management, and then we have this integration. So APIs, connectors, and gateways. So if any one of them is got infected, is got compromised by the security vulnerabilities, so that may lead to the complete control of the network by someone else apart in place of you. And there is a very important thing in Industry 4.0 application is implementations, is the kind of induction of the third-party softwares, the third-party agents into your system. So maybe you are erecting a factory, and that factory has the some machines from some party, third party, and which is not been audited, which is not been authorized, and that got inducted into the system. So the security model needs to be enough careful to audit, to think, to make secure the system which is coming from the third party. Or secondly, there may also be a scenario that you are designing a Industry 4.0 application for any of the factory, and you have been given the task of the designing of that system. Even your company has been given the task of management of those Industry 4.0 applications, the communication applications of the factory for some time. And later on, maybe after 2 years, you have been removed from the maintenance of those devices, and someone third party has been given the control of the third party agents have been given the control of those systems, like another company will be managing those Industry 4.0 applications of that factory. So still the security model needs to be so careful that through the network of that factory, one cannot enter into the cloud of your company, because we design such a kind of things many of the time that a common cloud structure, a common identity structure we manage for the different sites or for the different companies. So that common structure should not uh, should not make a compromising factor for the different sites of your company. So this is also a very challenging aspect in the Industry 4.0 applications. If we talk about these authentications, so in case of IoT, we have the network authentications to the data level authentication. So here is the step-by-step authentication, and integrity is managed in the IoT. And these are the vulnerable attack surfaces also. So starting from your user authentication to your network, and to the cloud service identification. So first the user which is entering into your network, that gets connected to your cloud. So thereafter, so through his device. So first it is the user ID and password authentications kind of thing. Thereafter, through the device who is getting connected, maybe through his mobile phone, maybe through the other IoT devices through which he is getting connected, that needs to be identified. And thereafter, if it gets identified through the means of a secure communication, so then it is the encryption. The communication will happen, and that must be in a communication. It must be in an encryption mechanism. And thereafter, we should always have a footprint of the signing in of those devices, which could be used later on for the verification or the future authentication purposes, or maybe for the auditing purposes. So these are the kind of connections. So I'm just discussing you about the further from these Industry 4.0 applications. So I have talked to you about the industrial IoT implementations, how they are there. Thereafter, how the Industry 4.0 implementations are posing a risk for the communications, for the attack surfaces, to the authentication levels, how these different authentication levels pose a risk to the communication. And then the supply chain trade-offs, that is also very much important, that uh, in the talk, and this is a very much a talk of the IoT security nowadays, about the supply chain trade-offs, because it induces a lot of third-party devices into the IoT implementations. So traditional supply chain, as all of you know, that the factory produces from the raw materials and it gets loaded onto a transportation, goes to a warehouse or maybe to uh, any of the distributor network, and that comes to you. Thereafter, it induced the software supply chains, where we have the applications. So it is a traditional goods supply chain, I can say. Thereafter, the software supply chain, which used to happen. So we have the source or dependencies of your files. Thereafter, some builds are being made on those source codes. Thereafter, it goes to the network. So it is deployed over the network, and from that network, people get download those softwares. So application repository and then the deployed system. So this is a software supply chain that is normally, but so this is in case of a normal application softwares I'm talking about. And still it has a limited number of layers where the security poses are there. So that is it. And that's why IT security management is a little easier than managing the IoT security. And here I'm talking about this embedded software supply chain. So in this embedded software supply chain, it is the source and dependencies that is there. That thereafter it is the custom codes are also. So maybe the different scenarios, different devices have the different levels of induction of the codes. Maybe some third-party hardware is also. Maybe you are using some chip, you are using some microcontroller which has a third-party hardware into it, like some communication mechanisms, some peripheral, which is a third-party peripheral that is into it. So those kind of things are into this system, and that may pose maybe your chip. Maybe you are using a company, you are using maybe a chip, and some communication mechanism has been inducted from a third party into this. So your microchip chip is enough secure, and maybe a third party chip which is from some any XYZ company had some attack surfaces, and that has got induced into your chip, and that may pose a security threat for your system. So custom codes are there, and the custom hardwares are there into this embedded software supply chain that makes a build system, and then the packaging. And thereafter, there are two things. One is the firmware and another is the hardware. So these two are there. So we have the two layers in IT security. We have to manage only about the deployed systems, about the deployed software's security. But in case of IoT security, we have to once manage about the firmware level security, and then it is the hardware level security. I think I have given you that a PCB level example also, that how it is important to look at the hardware level security also. So, and then the different repositories are there. So maybe the firmware over the updates, the FOTA you are implementing. So we have the image repository, we have the servers for the database management and for the image management, and we have the devices. So that is connected on a network. So this all is there in an embedded software supply chain, and it is large, it is complex to manage all these items into IoT security, and these all are actually has to be managed in IoT security domain. So just giving in a 4 points. So if it is a IoT security, so in IoT security, you have to look at the physical security, the data security, which is a confidentiality or data breaches, the cloud level security, which gives you authorizations, and then the authentications, so user level security. So these 4 layers are of the securities which is necessary in a IoT security. And this IoT security or IIoT security, I can say, so that is merged all the security domains. So starting from the physical layer of security, to the physical layer, the hardware level security I'm talking about, to the operational level of security, to the IT level. So our IoT devices are getting connected through some hubs or through the cloud, to the gateways they are connected. So the IT devices level security that we have to look at. And then once the data has been gathered, so information is there in the cloud. So we have to also look at the information security. So it has merged, IoT has merged all the levels of, or all these four layers of security in it. So I'm just describing it a little more, that what are these needs of these security are. So starting from the hardware level of a security in IoT, so we have all these four elements actually. So it is the hardware, first thing, which is at the physical layer. Thereafter your firmware, that is the firmware and the OS layer, I can say. Thereafter, if it is an IoT device, so it will get connected to the IoT network, so network level of security. And then once it has got connected on a network, so finally it is landing some data on a cloud, because we at the end of the day, the purpose of design of any IoT device is to gather the data from the environment, from some places, and then based on that, do some control over it, and do some kind of and generate some kind of analytics. So cloud security. So these four elements are the hardware, software, network, and cloud. These are four are the key elements of these any embedded and IoT systems. And that's why the security is a very much a necessary part of it. So if I'm going to talk about the hardware level of a security, so we have the trust platforms module. So the trust platforms are there. So each of the semiconductor companies has their trust platforms. So whether you are using the microchip platform, whether you are using the ARM platform or a Texas Instrument platform, so all of them have the trust platform modules, and they are so these trust platform modules, specifically about one of the trust platform module of a microchip, we have a discussion in our next masterclass, where we are going to talk about the measures of the security. Today it is majorly about different security scenarios, and in our next session we have the discussions on the how we can implement the securities. So trust platform modules are one of the ways through which we implement the security. So it is related to the chip actually, these trust. So this is a well protocol developed which is implemented on these semiconductor devices, through which we can ensure the security. So like you are designing any payment gateway device, or maybe kind of POS machines. So those devices require a trust platform-based devices. So that's why these at a hardware level, these trust platforms and hardware security modules are necessary, and we should have such kind of features while making a selection of any security device, while making any of the device which is to be designed for such a kind of a secure application. So it should have this passes of these platforms. Thereafter, the physically unclonable functions and secure elements. So this is at a hardware level. So like the device which you are making, that must have some kind of an identity which cannot be cloned. So like maybe in HP printers, if you try to use any local cartridges in the HP printer, they don't get inserted into it, or they don't get identified into the HP printers. Have you checked any time this thing? The HP printers don't support the local cartridges generally. Anyone has experienced this thing? You can refill those cartridges, but any XYZ company cartridges you cannot insert into it, because of the kind of yes, refilling is possible in the original cartridge, but any XYZ company cartridge you cannot enter into the HP printer, because of the kind of feature it has got available of that identity, that both of the device and the cartridge had some kind of identity match, and based on the identity match, only the cartridge will be allowed to print on the paper. So that's how the kind of a physical unclonable functions and secure element features that needs to be there in the processors, which makes it possible for to provide you the hardware level of a security, and that is a necessary thing. So thereafter, it is the secure OS. So you have got your hardware secure, and now you are using the RTOS, the real-time operating systems, onto your secure MCU. So it needs to be it needs to be a secure MCU product, which gives you a reliable communication over the cloud for the device authentications and for the network management, application management. So we have the various RTOS available, which is enough software, which is enough secure, like ARM Embed is a platform, or a Azure Sphere is a platform through which the IoT device security is possible. Thereafter, we are having increasing use of these ML and AI-based security solutions at the network level for the storage of the data and for the analysis of data. So it is at a network level. So it is necessary to ensure the network security to implement these security and the privacy measures into the design of IoT devices. And then it comes the cloud security. So it is the device to cloud thereafter. So there are the various measures in the cloud security. First, it is the device to cloud communication. Thereafter, it is the cloud to cloud communication. And then CA-based authentications, the trust platform based authentications, or so these are the kind of key based authentications I'm talking about, features which is there in a cloud. So this needs to be there in a cloud security for any of the kind of IoT security communication, and it should always be in a communication with that secure secure OS for the authentication and authorization of the IoT device which is got connected on the IoT network. So these are the four key elements of the IoT security. And then it comes the starting at the very beginning, it comes the hardware root of trust. So these are the various measures for the secure functionalities to get provided on any hardware IoT device. So it gives you the root of trust that we start with. So this all lies in the device itself. This is not on a network, but this lies in the device itself, that there is a secure boot feature. So if you see any of the ARM device booting, so any of the 32-bit device booting which has OS into it, so there is some boot level, there is just some secure boot level memory into it. So that secure boot level memory is there, and which is used for a secure boot feature. And there is a very small clock in which the glitch can cause that secure boot feature to get compromised. And maybe in the next session, we have a demo on this also, where we will be putting a glitch into the clock of ESP32. Maybe most of you are using these Arduino and ESP32 devices for designing the IoT devices. So I will show you that how these IoT, how these ESP32 devices can get compromised through just a glitch at the secure boot level. And you can just break the secure boot feature of that IoT device and can get parsed into that system. Thereafter, it is the secure firmware updates, the authentications, the key storage, thereafter the data privacy and communication. So these all are the secure functionalities that you should have at the level of the hardware root trust to talk about. And debug is a very important aspect for the security, because in most of these kind of systems, you will find that we have lots of debugging interfaces open. In these Arduino and ESP32 applications, if you see that there are lots of debugging applications remain open, your UART interfaces, your debugging interfaces that remain open. So that debugging interfaces are actually a very easy point of target for any of the security hacker to barge into your system. So whenever you are designing any of these systems, you should always take care of that, closing all those debugging points so that no debugging point open, there is a 99% chance of that your system will remain secure on a network. So if it is a security that we have to give from the chip to cloud level, so we have to talk both from the MCU partner and to the software partner, because the software partner takes care of that supply chain, and the MCU partner gives you the secure MCU boot feature, which gets connected to the cloud service providers, which gets connected to the cloud directly, because we have the now just-in-time registrations and secure device provisioning onto the cloud. So that is coming from the chip level directly. So whenever we are talking about the chip to cloud level, so we should be talking about the MCU and to the firmware, both of the sides. So from the firmware side, it gives you the flexibility to design of a system which gives a secure supply chain through which your devices are getting connected over the network. Or a secure MCU gives you the flexibilities, the facilities to get a boot onto the cloud directly. So if we are talking about this IoT and embedded end-to-end security, if I'm talking about, so it always remain a question of us that how we set up a secure device and how do we give a physically unclonable functions to our devices. So if it is the physically unclonable functions, means how we can give unique keys to our devices, how we can give unique root key from your secure element so that I can boot to the cloud directly. Once we are into the network, so how we can just prevent from the eva's dropping of your network resources. One cannot barge into my network and one cannot use my network resources by just eva's dropping into it. So it is the TLS level of security to the cloud level. So how we can secure the data which I'm receiving from the sensors, and how we can secure the different level of data controls which I'm generating for the devices. So from the IoT level, in the IoT, these are the foremost questions which is there in all the layers. So from the boot layer, this from the device layer, which is at a hardware level actually, to the IoT device level, which is MCU, which has the MCU, to the network level, which has these eva's dropping features, and to the application level, which is connected at the cloud. So these are the foremost questions which remain always into the case of the IoT security implementations. And based on this IoT security reference architecture is designed. So if you see that we have the level by level implementations of these devices. So we have the, at the very lower, it is the things layer. We have the sensors, the devices, the hardware, the PCBs, microcontrollers, OS, all these are there. Thereafter, we have the, which is at your premise. Thereafter, from the things layer, we go to the network, intra-network. So maybe these all things are there connected in your factory, in your home, in your office, and through the sensor gateway, you are connected to the intra-network. So maybe your office or your a factory has multiple networks. It is widespread in a long area. So maybe some environment sensors, maybe some kind of a machine data load gathering sensors, thereafter the actuator. So there are the different kind of devices and sensors are there in the factory that is connected through the sensor gateway through the intra network. And in the factory there are these kind of protocols are working on, whether it is the Wi-Fi, the Z-Wave, the 4G or 5G now it is, thereafter the LoRa. So all these are there, and through these intra-network protocols, through the intra-network gateways, we are connected to the core network router, and that core network router is actually going to connect to the cloud level storage, the database and the analytics softwares and analytics applications. And here at the person sitting at the another end, which has the application of these access of these devices. So he is connected to this cloud. So this application layer is connected to this cloud to gather, to see, monitor, and verify the data which is coming from the things layer. So this is a generic architecture of any of these IoT systems, IoT cloud, which is based on a cloud. So level by level, starting from the hardware level to the intra-network level, to the core network level, which is on a cellular waves or maybe MQTT level I'm talking about, to the cloud level and to the application layer. And here you can see that what are the different data they are gathering. So different data they are gathering at different layers. So sensor level layer data, thereafter it comes to the intra-network. So they have the packets, and then it comes at the platform layer, we have all the kind of the sensor data, passwords, credentials, all these things. And then it comes the application layer. And these are the different attack surfaces we have. So we have these, in the sensor layer, we have the spoofing and the tampering of the sensors. Thereafter, the EVAS droppings are there at the network layer. Thereafter, identity spoofing or the privilege tamperings are there in the cloud layer. Maybe one person is not to handle that data and someone has barged into it, and thereafter at the application layer. So this is the data that this is the kind of threats, those are there in the application layer. So denial of service attack or SQL injection application attack. So these things are there. So these are the IoT security reference architecture, and based on the attacks which is planned, based on these kind of attacks, we have the security mitigation plans and IoT security auditing plans. So in our next sessions, today I will be terminating the session up to this level only. And in our next session, we will be going to talk about how do we audit the security, and how do we make the plan for the mitigation of those security threats. And thereafter, we will be having a demo of a different security attacks, some application level security attacks. And we will see that what are the solutions we have available for the implementation of the IoT security in our devices, where we should look at what are the platforms we should look at. And these things are there. And to know more about the IoT security and all these things, so we have the internship programs running on IoT security and industrial IoT and industrial IoT security. So you may keep updated through our emails. We will give you mails once the batch will be made for that. So you can get know about that. And once, if you want to know more about the IoT security and implementation of the industrial IoTs, so you can just go through our internship programs also. I hope you have got some idea of the session of the IoT security requirements, the different aspects of it, and the architecture requirement of any IoT security reference architecture. And you would have got some insight into this. This is the feedback link I'm posted over here. You can give a feedback over this. It would be highly appreciated. And it would also be used please use your direct names onto this, so that we will, after this second day, we will be generating your certificates, e-certificates we will be generating. So these feedback names will be used for generating of your e-certificate. So carefully, please fill up these feedback forms so that we can generate the certificates in your name properly. And there are certain questions, if I can see. If you have some questions, you can put into it. And in the meantime, I just look at, okay. So Mr. Hemant has asked me that suppose there is a device like EcoDot, which can control home appliances. Can we not use a simple computer like a PC for its data processing and not connect it to a cloud? Let it process all the data it was using the computational capacity of the PC. At least the data will not get leaked from the user. You can, Mr. Hemant, yes, you can design a kind of EcoDot, a kind of an application for your local use only. But once it is, Amazon EcoDot is not just a device, but it has all the kind of AI and repository features also. And that gets continuously updated every minute, I can say, based on the user experiences. So, and it's able to make a control and the kind of experience that it can give to you, because it is gathering the experience from the millions of users which is connected to it. So if you are going to make a kind of a EcoDot solution, which is a local to only, it is possible, but it will have the your own experiences only. But if you are looking at a global experience, so then definitely you should have a kind of a device which is in IoT format, and maybe in your mobile phone format, or maybe a kind of a PC can also be made. An application could be made. Not has been made it yet, but you may think of designing a kind of an application which can take your voice interfaces, because it is the your voice interface is going to connect to the voice cloud, and from the voice cloud we are going to take the authorizations from the application cloud. So you may think of designing a solution where we are connecting, where we are getting connected to the through the voice interface. We are getting connected to the voice cloud and can get the info from the application cloud. So, and so if you have to get that global experience, it has to be connected, it has to be on a network, and it will have that IoT feature. And if you are want to design your own uh, local Amazon EcoDot solution, then it will have the local experience only. I hope this is the thing that I was, okay. Thank you. Thanks to all of you. So I hope all of you have enjoyed the session. Thank you. So hope to see you on next Saturday, that is on 26th of December. We will have the next part of this session, where we will be talking more about the mitigation plans and the auditing and the ways of making your IoT designs secure. So till then, if you have any question, you can ask me, or otherwise I can just end this session. And I have given you the feedback link. I'm just pasting it again. So if you have not filled up the feedback form, so you please fill up this feedback form so that we can have the e-certificates for you after the second day of this session. Okay. So thanks to all of you for joining in, for spending time with us. Welcome. I will be ending this session. See you on next session. Thank you. Good night.